Well, hey everyone, today we're looking at the next video here in the AP Statistics A final. We're looking today at questions numbers 41 through 47. And we're starting it off with 41 here. Which of the following is true for every random variable? So we can just take a look at number 1. It takes on a numerical or categorical value. So that's actually not correct. Random variables have to take on a numerical value. They can't take on any categorical values. So we'll mark that one wrong, and we'll also mark anything that includes number 1 as incorrect. So it looks like we can just take a look at question 2 and decide from there. It describes the result of a random phenomenon. That's true. There has to be some kind of a probabilistic outcome for each of the numerical values in a random variable. And number 3, its behavior can be described by a probability distribution. And that is also correct. So since numbers 2 and 3 are both correct, our correct answer for question 41 is letter D. Moving it over to the next one, number 42, we have a random variable x has a probability with the following description. So here we have a lot of probabilities that do not have any numerical value. Instead, they are algebraic: 2k, 3k, 13k, and 12k. So our first task here is probably going to be figuring out what is the value of k. So first off, all of these probabilities have to add up to the number 1, since a probability distribution has to add up to 100%. That gets me that 20k equals 1, or k equals 0.05. Now that we've done that, we can put together the rest of this probability distribution numerically. So with k equals 0.05, 2k is 0.10, 3k is 0.15, 13k is 0.65, and 2k again is 0.10. Let's do a quick check to make sure that this probability distribution is valid. So let's make sure it adds up to 1, and it does. So this looks good. And then the last step here is to figure out this probability that x is strictly greater than 2. That's the probability that x equals 0, and plus the probability that x equals 1. We don't include 2 here because we're looking at strictly greater than 2. Substituting, that's 0.10 plus 0.15, and that gives me 0.25, making B the correct answer. All right, checking out number 43. Let's make this a little bit smaller. We have this continuous random variable here, and this time we need to find the height of this distribution. We can't find area since this is going to be a rectangle. We're going to have to find that the area is equal to 1. So we know the area is equal to base times height. The base of this rectangle is 2. So that's 2 units down there. And we have an unknown height, so we'll call that x. So 2 times the height is equal to 1. Doing a little bit of algebra, that tells me that the height of this curve is 0.5. Now the next part here is we want the probability that x is at least 1.5. So let's locate 1.5. And we'll create that rectangle of the values that are greater than 1.5. So now the probability that x is greater than 1.5 is going to be the same as the area here. So this area is also equal to a base times height. The base in the height are both 0.5. So we're looking at this distance right here from 1.5 to 2 is 0.5. And then the height of this rectangle is also 0.5. We found that out earlier. And that gives me that the area of that rectangle is 0.5 or 0.25. And then finally, the probability that x is greater than 1.5, at least 1.5, is the same as that area, and that's 0.25. All right. 44, we've got some random variables. I'm seeing a mean and a standard deviation. Let's see how we do this one. A vending machine operator has determined that the number of candy bars sold per week by a certain machine is a random variable with a mean of 125 and a standard deviation of 0.7. Notice that this is not saying anything about normal. I think once we've learned about the normal curve, we tend to get enamored with it and we want to use it for everything. But there's nothing here that says normal, so I'm going to not use a normal distribution unless I see the word normal. His profit is 0.25 cents, and it costs him $5 a week to maintain the machine and rent space for it. Which of the following gives the correct mean and standard deviation for y, the profit he earns from this machine in a randomly selected week? Our first task here is to figure out the profit equation. So the profit's definitely going to be that how many candy bars were sold multiplied by the profit on each bar. So if we call x the number of candy bars sold, then the profit, well, that's going to be 0.25x minus the weekly cost, which was $5. So y is equal to 0.25x minus 5. Now we can move on to the job of finding the mean of y. So the mean of the profit undergoes the exact same transformation as y does to get from x to y. So the mean of the profits is going to be 0.25 multiplied by the mean of the number of candy bars sold minus that $5 again. So that's 0.25 multiplied by 125 minus 5. Now that 125 is going to be the mean number of candy bars sold. That's going to give me a mean of 26.25, which narrows down our answer choices quite a bit. We're down to 50-50. And now we just have to find our standard deviation. Now the standard deviation formula, and this is the place where a lot of people mess up. The standard deviation is not affected by adding and subtracting. So this minus 5 over here, that's not going to play any part in our standard deviation formula. The only thing that affects the standard deviation is the multiplication part, multiplying by 0.25. That's why you see the standard deviation for y. That's why you see that that's only equal to 0.25 multiplied by the standard deviation of x. Since the standard deviation is 7, we get a standard deviation of 1.75, which means that E is our final answer here for question 44. Taking a look now at 45, we have got insert tab A into tab B is something that you might read in the assembly instructions for prefabricated bookshelves. Suppose that tab A varies in size according to a normal distribution. There's that normal word. With a mean of 30 and a standard deviation of 0.25, and the size of slot B is normally distributed with a mean of 32 millimeters and a standard deviation of 0.8. Now the two parts are randomly and independently selected for packaging, so what is the probability that tab A will not fit into slot B? So the question we need to ask ourselves for this one is, well, when would tab A not fit into tab B? Well, that would occur when tab A is greater than slot B. Or to put it another way, that happens when tab A is greater than slot B. Now, since these are both normally distributed, well then tab A minus slot B is also normally distributed. The mean is going to be the mean of A minus the mean of B, and the standard deviation is going to be the square root of the variance of A plus the variance of B. Now, remember that with standard deviations, we're always adding variances to find the new variance, and then we square root to find the new standard deviation. Putting some numbers together, we get 30 minus 32 for the mean, and the square root of 0.5 squared plus 0.8 squared. So that's a normal distribution with a mean of -2 and a standard deviation of 0.9434. Since we want to know the probability that tab A minus slot B is normal, or is greater than 0, we're going to have to normalize the number 0. So the z-score is going to be equal to the number minus the mean divided by the standard deviation. For us, our number is 0. That's what we're trying to normalize. Minus the mean of -2 divided by the standard deviation of 0.9434. So that's a z-score of 2.120. Going back to our problem, the main problem, we've got the probability of tab A minus tab B is greater than 0. That's going to be equivalent to the probability that z is greater than 2.120. Grabbing our calculator, we go to the distribution menu and we use normal CDF. And we want to know greater than 2.120. So that's my lower, and my upper is going to be infinity. Since the 2.120 is a z-score, I'm going to leave the mean and the standard deviation as 0 and 1. And we will get 0.170. And that leads us, as our correct answer is letter B. So that worked out nicely. Let's take a look at 46. We have a worn out bottling machine. Does not apply properly apply caps to 5% of the bottles that it fills. Now suppose we select 20 bottles from that machine. And what's the probability that exactly 2 caps have been improperly applied? So I think the trap here, after we just did that normal distribution, the trap here might be thinking that this is actually a normal distribution. And there's nothing here that says that there's a normal distribution. There's no mean, there's no standard deviation, and most importantly, we don't even see the word normal here. So we have to decide what kind of distribution are we talking about here, because we're talking about 2 caps out of 20. This does seem to be like it's a binomial distribution. So before we go full in on binomial distribution, let's just kind of make sure by going through the 4 conditions for a binomial distribution. So for B, is this binary? Well, we have a proper cap or an improper cap. That works. For independent, that means that the outcome of cap 1 should not affect the outcome of cap 2. And there's nothing here to say that it is independent or not. So I think we might have to go on assumption on this one. Since this is a machine we're talking about, it's probably going to be the independence is going to work out for us. For the same number or a number of trials, well, we know we're applying 20 bottles. And for same probability of success, this one we have to put our mind at work here, because success now is going to mean that an improper cap has been applied. So success is going to have a probability of 0.05, and failure, a properly fitted cap, is going to have a probability of 0.95. So this does seem like we have a binomial distribution. And again, the thing that kind of clued me into a binomial distribution is that we're talking about 2 caps out of 20, not just 1 cap. So if x is the number of improperly fitted caps, that means x is going to be a binomial distribution with a number of trials of 20 and a standard deviation of not standard deviation, probability of success is 0.05. So what we want to know is what's the probability that x equals 2. Okay, so this is, since we know this is a binomial distribution, we have a formula for that. So for writing down formulas, that is a probability, that is 2 choose 20, 0.05 squared, and 0.95 to the 18th power. Grabbing our calculator, we're actually not going to use that formula. We're going to write it down in our paper, but we're not going to actually use that. We're going to use binomial PDF. 20 trials, probability of success is 0.05. And I'm putting that in the wrong place. Hold on. There we go. 20.05 for the probability of success. And the x value is 2. And that gives us the number 1887. Which means that B is our correct answer here for question 46. 47, this is the last one we're going to do in this video. We have the poll showing that 60% of adults in a large town are registered as Democrats. A newspaper reporter wants to interview a local Democrat regarding the recent decision by City Council. On average, how many people will the reporter stop before he finds his first Democrat? So I read this and I think immediately that this is a geometric distribution because we're going to stop as soon as we find our first Democrat. There's not a set number of trials. Let's go over, just like the previous one, we went over bins. Now we're going to go over bits for that geometric distribution. So this is a binary outcome. Either we get a Democrat or we don't get a Democrat. Independence, we have outcome 1 does not affect outcome 2. Kind of like I feel like I've been saying a lot, the independence is the hardest one to really think about. It's the hardest one for me to convince myself because I imagine that if we go to a place with a lot of Democrats, then the probability that the first person is Democrat is going to affect the probability that the second person is a Democrat. But academically speaking, we just have to kind of roll with it. So we're going to say that this is independent. Outcome 1 does not affect outcome of person 2. T, we're interested in the number of trials before our first success, which would be a Democrat in this case. And same probabilities of success. Here we're saying it's 0.60. So if X is going to be our trial number of the first Democrat, then X is a geometric distribution. So the mean of that geometric distribution, that's going to be 1 over P. That's 1 over 6. 1 over 0.6, that is. And that's equal to 1.67. So for 47, we get a correct answer of C. And that will do it for this video. Our next video will be the last video here for the practice final on AP Statistics Semester A, and we'll see you here for that one.